So, boys and girls, tonight we're looking at this infrared heater. Doesn't turn on. I've got a couple of these. This one doesn't turn on and the other one is always on. They are 2 kilowatts in power. So, sounds like a control issue at both ends. The one that's always on, I'm going to guess, is probably a stuck relay. Unless they're triac driven, but I don't think they would be. Just, I guess, because of the amount of power involved and how long they're on for, they'd get probably too hot. The triac needs some decent heat sinking and a fan perhaps, but these don't have that. Got your infrared sensor at this end. Yeah, it's just a heater, pretty straightforward. The one that doesn't turn on, that'll be interesting, but I think the other one that's stuck on is probably just a relay fused together. Not sure how to get these apart yet. They look like they're assembled in one direction only. So we'll have a look. I think it's this end on the left. That's where the power cable goes in. And I'm thinking that this end must unclip and the guts of it slides out. It's got some indentations in the case that look like where things would lock in, and there's no screws. So let's have a poke at that clip there and see if it's going to pop out. I may just release the chrome collar, or I may do nothing. Doesn't look like it wants to move very well. So if it is, yeah, it doesn't feel like it wants to come apart at all. Can't flex it that way. I don't think there's anything under here that we can reference or really get in the edge in between. This whole cover might slide off. There's nothing. There's an indentation here as well, and then one directly on the other side there. So they must come over and click onto place, which means it must just come off somehow. But I'm thinking they're designed to be assembled, click on, and that's it. I don't know what this is here, unless there's a screw in the middle maybe. It's just a rubber bung. You'd think they'd be able to come apart for servicing. Ah, it's a switch. So I wonder, let's plug it in and see if that switch turns it on. Maybe this is blind to the remote control, which I know the controllers work. Let's plug that in. I don't hear anything click. There's definitely nothing warming up. So she's brain dead, all right. Well, that's going to pop off. If you're wondering, the brand is Instant Heater. Heater model number SNBHTR. There's some more wording and fine print that I can't read, but looks like this might come off. There we go. It's unclipping around the edge. So we will follow the edge, see where it takes us. Let's just hope that kind of release is not permanent. Almost there. Almost there. Oh, feels like it's clicking back together. Well, that was definitely a permanent release. These little tags that go through appear to have been stuck on the backside. So that's not good. So then what actually releases this? We still don't know. I wonder if it's something as stupid as the tension on the power cable. So I have to release the gland in the back and it will fall out. Wouldn't that be dumb? Let's undo the gland. There is a couple of rivets there. I wonder if that's how it's assembled and you need to drill them out. I bet you it is. Whoops. Well, it's dead anyway. That's the beauty of it, right? You can't make it any worse. So I'm now thinking that these rivets might be our only way in. I'm wondering if they are metal. Let's just see if they are metal. Yeah, they're definitely metal. They're not plastic stakes that have been melted over to hold it. So here we go. Take the head off that one. And will it pop out? I get under the edge here and lever it. Wonder if that's gonna let go, or maybe I need to encourage whatever they are. Maybe I need to drill it a bit more. I'm thinking I just need to maybe drill it a little bit deeper. Maybe I need a smaller drill bit to get the center out. Maybe I should try and lever on it as well, just to encourage it to separate. And kind of see something down in there when I peer in the side, but I don't really know what's going on still. There it goes. Oh no, there we are. Maybe a... okay, I just needed a bit of a push after I drilled with the bigger one. Okay, let's vacuum this mess up. Now this should just slide out, but now I'm starting to wonder. Let's have a look. There's the end, and that may have all been in vain because it's still attached somewhere. So, oh no, that just came off. All right, what do we got going on there? I went about that wrong. This should have just popped off, but the way I was doing it, I guess, was getting just the right angle to keep it under the lip because of the shape of it. But that's fine. We can deal with that later. Here we can see we have the PCB. On the rivets we drilled out, it was just holding a heat sink. It wasn't holding everything together. So we can reattach that at some point. On the heat sink is a triac. There's no relay. I cannot see any relays on that board. We have a couple of capacitors. We have our controller. There's a beeper, speaker, and there's a fuse down in here. So here we have, we got this wire goes out to the element, as does this one. So one down each end. We have our mains coming in with 3 wires here, a triac, and yeah, the fuse is right down in here. Very, very basic setup. There's not even a switching supply for the voltage required to run that chip, so possibly even just a resistor divider. Just a resistor divider. Now I'm thinking this is actually a motion or human presence sensor, because this plastic is tinted. You can kind of see behind through it there, and the infrared sensor is behind the tinted plastic for the remote. It's kind of cool if you walk in the room and then the heater turns on. And there's a little 7-segment display here that must shine through, indicating set and current temperature perhaps. Well, that's fairly easy. With the board is attached to screws. How did this all stay in there then? Was it just that chrome ring? I need to figure that out so I can open the other one a little more gracefully. It looks like that chrome ring could have stayed on, because the way that this was sitting in there, it seemed like it was just a perfect fit under the lip there. Just a perfect fit like that. I thought the chrome bezel was held on with plastic stakes or something, but no. All the bits I snapped off actually have a little screw in the end of them. So I think these wires are just spade terminals. Let's see if I can pull them off. Get under the edge of the spade terminal and just force it up. There we go. That's better. And then the other red from the heating element coming in from the left end of the heating element. And we're loose. So we have the fuse, we've got a resistor here, then we've got a fuse. And I think that's a fuse actually feeding the heater. No, that's actually the, yeah, okay, so phase comes in directly to the heating element, and the fuse is for the circuit, and then neutral is switched through the triac. So let's check the fuse, I guess, because it was completely unresponsive. Alrighty, listen for the beep as we go in for the fuse. Cool, our fuse is good. Let's check that resistor, because high powered resistors, especially low value ones, can go high value. 20 ohms, that is correct. Red, black, black on the color code. And there's a couple diodes. We have a couple diodes down here. I haven't quite worked out how they're dropping 230 to feed that IC, unless that IC runs at 230. No, it's a 16 volt capacitor, so there will be something going on. There's a 10 volt cap in there as well. Both the smaller ones are 10 volt. Let's check the diodes. And red on the anode. And we have 0.6 drop is fine, and the other one is fine. And this that's NTC, so that'll be a temperature monitoring device that looks like a diode. It's in a glass package. We have that diode there. I wonder if it measures like a diode. Let's have a look. Yeah, it does. I have heard they can use diodes properties as temperature sensing. There's a 200 ohm resistor there. Make sure that's okay. It is. Maybe need to go under the microscope. I can hear something rattling around in there. So now what I'm thinking is that this is a safety device, so that if the heater ever rolled over and was like face down on the ground, it would turn off, just to make sure that it's face up. I don't think this is a relay. I think it's a little ball in there that hits contacts at a certain angle and causes the thing to turn off. So that's interesting. But I don't think that would stop the whole thing running, but it might do. Maybe that's gone bad. I think I'm going to have to get power applied to this and do some fault finding. Let's plug the power leads back in. Phase and neutral hooked up. The heatsink is not connected through the triac to either of those. It's the tag on this is isolated, unlike some devices where it's the center pin. Just got to make sure that nothing on this board touches the chassis at all, as that will be mains potential. So we'll work on it that way, plug it in and see what happens. But yeah, I've got the heater still unplugged there. Now let's see if we have a voltage on this capacitor. Now remember, it might only be 5 volts, but you still can't touch that because it is mains potential. If it's just a basic voltage divider off the mains itself, it will hurt you. It's not the secondary side of a transformer, for example. So let's select voltage there, and I'm just going to probe directly on that there without shorting the leads together, and we have nothing. We have 0 volts coming through. It is flickering a little bit, but by and large there's nothing there. So we have a problem with wherever that comes from. And it could be one of these capacitors actually. If it's gone bad, it's not allowing anything through, if that's how they're doing it. So I've unplugged it, and we'll take the board off the back of the plastic here and see what's going on. Let me just double check. I just noticed a diode down in here. I can't remember if I checked that one. Could be acting as a Zener to create the rail. Oh look, looks like a short to me. There's one over here as well, which was okay. I think it could just be a shorted Zener used for regulating the supply to that chip, because maybe that is going to show up too easily. We have this capacitor here with no voltage on it. There's a trace that runs off from it to here, and that's where that diode is there. That's probably why we have no voltage on that cap. So I need to find out what that is. Now, let me get that off and see if I can identify it. It says D3, not ZD3, but the way it's hooked up to me says Zener. So there it is down in there, underneath that capacitor, and I can't use hot air in here because it'll upset this guy. It was really close, so I'm going to just get the solder iron across both ends, and it should fall off once they're all liquid. It might be easier to make one good one out of 2 if I took the board out of the other one. It's going to have a shorted triac, so I could swap the triacs. For it to be on all the time without a relay, and it has to go through the triac, it must be a failed triac. But let's just remove this for now, and we can. It could even be a short on this board somewhere else. But let's have a shot at testing that out of circuit. I should have stuck one end down so it's easier to handle. Looked like a low resistance more than a short because it wasn't dead zero. But let's see what the diode reading says. No, that's shorted. 0.06. Definitely the issue. And when I check the board again, nothing. Yeah, that looks good to me. And because it's got a 10 volt cap there, I suppose it could be maybe a 5 volt Zener. That would be a really good guess. I can see what that IC number is and look up a data sheet, and then that'll give us a voltage range as well. Data sheet for that little guy says 6 volts max, so I think a 5 volt Zener would be more than suitable. So knowing that it runs on 5 volts, I've just attached a couple of wires where that Zener went, and we will put 5 volts in from our bench supply and see if it lights up. Because if it's died as a result of some surge or something, and there's no point really trying to find a Zener for it, I don't have one, so I'm going to have to buy one. Why spend money to find out that it's brain dead? So looking for it to light up. Now, hey, look at that. It's got an error. Can I turn it off? Does the remote work? Maybe it doesn't work under error state. Okay, it has an error. It'd be to do with current sensing or something through the heater element. But at least we know that it is working. So we can find ourselves a 5-volt Zener and be confident that that's going to solve the problem. It's not going to solve our problem of how I destroyed the thing getting it apart, but there we are. Just been out and procured a Zener. Not a surface mount one, no local parts shop is decent enough to carry a good range of parts. There's probably bugger all people that would buy them. I do have a leaded Zener that we will turn into an SMD Zener at 5.1 volt rating. So technically I could just go like that and we'll bend the leg and it'll sit there. So that'll sit there. You can anchor it across the top two, and then I'll loop the other one around to the other pad. Oh yeah, that'll work perfectly once I shorten that. You know, a teacher once said to me, well, the whole class actually, if you cut the leg on a component, that the vibration can travel back up in and damage the component. The sudden shockwave of the leg being split. And I thought, that sounds like a load of bollocks. And to be honest, I've never had it be a problem. I'm going to have to move it a little bit because it's going to get under the screw head there. So I'll just tack that top down first. That's a horrible angle. Just going to mess everything up. Trying to work around the camera too. I mean, blimmin' heck. Let's get it that way, maybe. That's better. Once I anchor the other side, I can just freshen the joint up a little, but at least it's tacked down for now. I do need to get that away from the screw head. Let's feed a screw in there and just see how bad it's going to be. Hopefully not too bad. There we go. So it's going to miss that altogether if I was to permanently mount it there. The screw head is isolated from everything anyway, so it wouldn't matter if it did make some contact, but I don't want to crush it under the screw. Here we go. The body of the diode is holding the leg up off the board, so it's just not worth trying to anchor it to the SMD. It would take a big blob of solder to do that. This is not something that's in you know, moved around a lot, so it's not going to shake loose over time. It's mounted to a wall or other such structure. Well, moment of truth. I've got it somewhat connected back up together, and the element is also connected. So let's see what happens. Woohoo! No error. We're on 0. If I push the 4, 0. So I'm not sure what that means. Level 4. Okay, 4 levels of heat. Oh, I can feel the heat coming off that already. Alright. We got a level 1. that's quite warm. Yeah, it's starting to radiate. If we go to 4, that's really taking off, and you can probably see it glowing. So I'll just turn that off there, because we don't want to overheat our triac, although it's probably not using the body for a lot of heat sinking through those rivets. But yeah, excellent. I like it. 4. That looks a lot better on camera than it looks in real life. That's a decent orange going on there. Could do with one of those above my bench. It's a bit cold these days, given the season we're in. Get down to 1. We'll go to 2. Make sure we do have some variation. We do. 3, 4. Wow. Back to 1. Back to off. So the easiest thing to do is to pull these studs out. So of course we drilled off the back of them, and then that part was left through the heatsink with a little sort of star washer there, where you can push it on one way and it won't come off the other way very easily. So just bent that until it came off. Get both of them off, and the easiest thing to do is going to be to put a nut and bolt just through the hole and into the chassis. So let's see what I've got in the way of spare things like that. Found a couple of screws that'll do the trick, but need to make the holes in the back big enough. The holes in the heatsink are bigger than the screw, but there's a washer, so it'll take that up. So that's going to do it, I think. There we go. That'll go back on there. It's pretty. It's bent to fit. That would have been a little bit of a standoff with the previous mounting studs, though. There was. Unless I can put a little bit of a spacer behind. I wonder if I've got any. I could just stack one of these flat nuts, one of those nuts in behind first. That may, just see if that's going to help at all. Slightly bigger than the thread, so, and then that'll hold that off there. Yeah, okay, maybe I'll do that. That would be nicer, wouldn't it? So let's do that and get the second one. Pop that on there. There you go. And then that'll give us enough thread to put the nut on. Before we do that though, I'm just going to stick some Loctite, some thread locker on there, just to prevent it coming undone inadvertently, hopefully. Hopefully. Some of that on there. Tighten that up from, it's going to be the easiest way to do that if I grab that with some pliers and hit it with a screwdriver from the back. Make that nice and tight. And the way thread locker works is when it squeezes between the threads, that's how I understand it to work. You squeeze it between the threads, and the air's squeezed out, so it goes hard. It's all tightened up. Get that back onto the... I wonder if I should try and get the chrome bezel back on that first, maybe, and then reassemble it. I was able to reuse the original screws. There was just a little bit of length in them to reach the broken stubs, so we'll see how that goes and play it by ear. Let's reattach that. Get them all in loosely first, just to make sure that the board stays in over the holes. Some things you can tighten up and it'll shift such that you can't get another screw in. Now we need to slide it in. There's not going to be a lot of movement, but let's see. All those wires going to bunch up. Pick the edges behind. There we go. Is that actually going under? Not quite. There we go, like that, perhaps. There we go. She's snug all right. Hey, back in. I don't know how I'm going to get the other one out, because that seems like a fairly tight fit when it does go in. We'll just have to massage it, I guess. Better give it one last test, of course. Make sure it's not touching anything inside that shouldn't, and turn it on. What do we got? Level 1. That's warming up. Level 2. Definitely more to it. Level 3. You can feel the temperature increase faster. And level 4, it's just going to go ham. I love the filament in that. It's like rope. Maybe it's a rope made of carbon. It's pretty cool. See, it's like a black rope, which is quite interesting. And if I turn it off, yeah, it has a really black appearance to it, but kind of woven like rope. And then of course you turn it on and she gets nice and hot. Well, I was thinking, oh, I could just let's go straight into the next heater, but it's already been about 40 minutes of footage, so I think that's long enough. Let's look at the other one as a separate problem. If you like that, please give it a thumbs up, like, subscribe, all the usual stuff that YouTube viewers do. And we'll catch you in the next one.